Alright, hello everybody. I'm going to be working on the math minutes from the 5th grade alternative learning packet. Couple things I want to comment on about this. First of all, the workroom attendants who were working on Friday to copy all of the materials that were sent home for the entire school made a mistake with our classroom's alternative learning packet. What you guys got is only one-sided. On parent view, your parents can access the actual packet, front and back. We scanned it and uploaded it. So it is on parent view and you can access both sides. I'm sorry that happened, but they were literally copying until 3:05 as I was handing materials to you at dismissal. So, we were the unlucky class to get the one-sided packet. I'm going to skip a number of pages and get to the math minutes because that's what I want to focus on for right now. And let's see. Please be patient with me as I am not quite sure what I'm doing here. Alright, there's got to be a faster way. Let's try this. Okay. So what I'm going over today in this video, I'm hoping to create more videos today to go over some of these materials. We were sort of waiting on information from the division about what we were allowed to post online. It looks like they're letting us post materials and resources, so I'm going to start working on that today, but I apologize that I haven't done anything yet. I was kind of waiting. Alright, so here is the first math minute that's in your 5th grade alternative learning packet. I'm going to go over as much of this as I can and you can follow along. You should be checking your work. You also should have already done this. It doesn't help you to copy from me off the board. You should try it first, okay? Alright, so this, the Monday problems here, the first one is 1 24/100 times 8/10. And looking at this, let's see if I can zoom in just a little bit more. The stylus that I'm using is not ideal, just so you know. My handwriting may not be pretty. Okay, so in looking at this, the first factor here is 3 digits, and the second factor is 2 digits. And you know what? I'm going to say 1 digit because that 0 I don't really need. I'm going to put the one with the most number of digits on top, like this. 1 and 24/100 times 8/10. Let's see. Trying to put my decimal point. Okay, well, that's going to be a decimal point. Okay. Now, because we're multiplying, I don't necessarily have to line up I don't have to line them up by their place value. That doesn't help me. When I'm multiplying, it actually helps me to sort of ignore the decimal points. Just pretend like I'm multiplying 124 times 8. Then the digits will be the same. What I'll have to figure out at the end is where to put the decimal point, and we can estimate to figure that out. Alright, so 1 24/100, I can estimate that's about 1. Okay? If you had $1.24, you have about $1. Okay? Again, I don't need to make a perfect estimate. I don't need to round perfectly. I'm just trying to help myself at the end when I'm figuring out where to put the decimal point. 8/10. So if you have about 80 cents, you have almost $1. So we can say that the product will be somewhat close to 1. Okay. Now, since we're multiplying 124 times 8, and we're ignoring those decimal points for now, we're going to have to figure out at the end, how do I put the decimal point so that it's close to 1 whole? Okay. So now I can multiply like normal. 8 times 4 is 32. I'm going to carry that 30. Okay, now we're pretending like this is 124, so we're putting the 30 on top of the 20 in the tens place. You guys know that 4 hundredths times 8 tenths would actually be 32 thousandths. Okay, but again, we're just pretending and ignoring the decimal point. All right, 8 times 2 is 16, plus the 3 is 19. 8 times 1 is 8, plus the 1 is 9. 992 is nowhere close to 1. So I need to figure out where to put the decimal point to make it close to 1 whole. Okay, so let's see here. 99 and 2 tenths? Definitely not. Okay, 9 and 92 hundredths? Not close to 1. 992 thousandths is close to 1. It's very close to 1. In fact, it's only 8 thousandths away. So I know this is where I put the decimal point. The only other option, or the other option I have, is to go decimal point 0, and this becomes 992 ten thousandths, which is not close to 1. So our first placement of the decimal point, or this one right here, is correct. That's your answer. Okay. So I'm going to go ahead and erase this here just to give myself enough time, or I'm sorry, to give myself enough space with number 2. Okay, so here's number 2, 49 hundredths times 17 hundredths. Again, I'm going to just ignore these zeros because if I were to add them, they would just make me do more work, and they don't help me get. And they would get me the same answer, but I'd have to do more work to get there, and I'm not interested in that. I want to be efficient. Okay, so both factors have 2 digits. 49 hundredths times 17 hundredths, like this. Okay, so I like all the colors I have. I'm going to go purple now. All right, so now estimating these is a little trickier. We have to be creative. It's not as simple as rounding to the nearest whole number, because if we were to do that, both factors would round to 0. So I'm going to be a little bit creative here. Instead of rounding to the nearest whole number, I'm just going to sort of round so that I can get the answer fast. 49 hundredths, we can say that's about, let's see here. We can say that's about 5 tenths, okay, or 50 cents, 50 hundredths. 17 hundredths. Now, hear me out. I know it rounds to 2 tenths, so I could do that. But when I'm multiplying mentally in my head, it's easier for me to make it a 1. Okay, 5 tenths times 1 tenth. I'm basically saying half of 1 tenth is 5 hundredths. Okay. There we go. Okay. Now, the whole point of me doing what I just did right here off to the side, the whole point of this is to just get a good estimate so I know where to put the decimal point. Because now I'm going to multiply and kind of ignore these decimal points here. I'm going to ignore those. 49 times 17 is going to give me a pretty big number. Okay? It's going to give me a number that's probably in the hundreds. And I need to know at the end that my answer needs to be closer to 5 hundredths. Okay? Alright, so let's go ahead and multiply now. Alright, 7 times 9 is 63. 7 times 4 is 28, plus the 6 makes 34. Okay, like, because I'm pretending it's 49 times 17, I need to put a 0 here. Because now I'm multiplying 1 times 9, but that's not really a 1, it would be a 10. 10 times 9 is 90, so I've got to put that 0 there. And I don't want to confuse myself with that 6 up there. 1 times 4 is 4. Now I need to add these together. $833. Okay. So now that I have 833, I need my answer to be somewhat close to 5/100ths. Okay? This is why your estimate helps you, because you need to figure out where to put the decimal point. All right. So if I were to put the decimal point here, it'd be 833. That's nowhere close to 5/100ths. Okay? If I were to put the decimal point here, it'd be 83 3/10. Nowhere close to 5/100ths. If I were to put the decimal point here, that'd be 8 33/100ths. Again, not close to 5/100ths. Here, 833 thousandths. Still not close to 5/100ths. I'm going to have to put a 0 here and then put the decimal point. 833 10,000ths. Okay, let's just focus on this 8. 8/100ths is pretty close to 5/100ths. So I know that's how I got the answer. Now, I forgot to mention in this first one here, but I will do it over here because it does help us, especially if this whole thing confused you. But we did learn a trick this year about figuring out where to put the decimal point. We can look at each of the factors. In 49/100ths right here, there's 2 digits to the right of the decimal point. 17/100ths, there's 2 digits to the right of the decimal point. 2 and 2 make 4. Okay? That means that in the product, I should have 4 digits to the right of the decimal point. 1, 2, 3, 4. Good. Okay? Now over here, just to reinforce that trick, there's 1, 2, 3 digits to the right of the decimal point. So the answer that we got should have 3 digits to the right of the decimal point. Okay? All right. Let's move on. It says, Tuesday, write an open sentence. Okay, so we learned about equations and expressions. Equations have an equal sign. This open sentence will have an equal sign, but we don't know if it's going to be an equation yet. We have to see if they tell you what the balanced equation would be. All right, so I'm going to go ahead and highlight in here. It says Alex and Sam sold tickets for a concert. Sam sold tea. Alex sold 10 tickets more than Sam sold. Okay. Write an open sentence that shows the number of tickets that Alex sold. All right. I'm going to draw a bar model to show. Let's see. To show how much each boy sold. Looking at the problem, I can see that Alex sold more than Sam. So I'm going to make a bar model for Alex that's bigger. Okay, and I'm going to label it Alex. All right. Now Sam sold less. So I'm going to make a smaller bar. Sam. And they told us Sam sold T tickets. That variable T stands for a value. We just don't know what it is. All right, the next part of the problem is, or the next part of this word problem is Alex sold 10 tickets more than Sam sold. So he sold as much as Sam plus 10. So he sold T, this amount right here, plus 10 more. This part of the bar model right here represents 10. This part of the bar model here represents T. Okay, it says write an open sentence that shows the number of tickets that Alex sold. So we're looking at the Alex bar model, and I see the Alex bar model is showing me T plus 10. Okay, T plus 10, we could even do this, equals A, equals how much Alex sold. Now to check your work, let's come up with, so write this down because I'm about to erase it. T plus 10 equals A. T plus 10 would be the expression. I'm about to erase, okay, so make sure you have that. Make sure you have the bar models. You guys know I love bar models. Okay. T plus 10. Let's come up with some values here. Let's pretend Alex. Let's pretend that Sam sold, let's say the T represents 5. Sam sold 5 tickets to the concert. Okay? That would mean that Alex would sell 15 because 5 plus 10 equals 15. Let's see if that makes sense. Alex sold 10 tickets more than Sam sold. Yep, 15 is 10 more. Perfect. Okay, let's move down to Juan. Juan bought toy trains at the store. He gave 15 away and had 9 left. Write the expression to show how many trains he bought. Alright, so I'm going to break this one down just because it makes it a little bit easier for me. I'm going to do this. I'm going to cover up the rest and sort of go one step at a time. Sometimes, at least for me, these story problems that they give me are so long that I get lost in all the sentences, and it helps me to just go one sentence at a time. Let's start with Juan bought toy trains at the store. Okay, I can put a T to stand for toy trains. Okay, now let's erase and read the next part. Ooh, I need a smaller eraser. It's too big. Let's try that. He gave 15 away. That sounds like subtraction. Sounds like we're subtracting 15. Ooh, and had 9 left. So when he started with the T trains, that number represents what he started with. The 15 represents what he gave away. Now the 9 represents what he had left. Okay, so maybe you see how kind of covering it up and going one section at a time can help. Write the expression to show how many trains he had bought. Okay, this is actually an equation. T minus 15 equals 9. So this should say equation, and I'm sorry that it doesn't, because there's only one value for T that's possible. I'm going to erase my writing off to the side here so that we can solve it. Now, you're not supposed to solve in 5th grade. That's a 6th grade thing, but I believe in you. And I think sometimes solving the equations helps you check your work. All right, so what value for t would make sense here? So he had a number of trains, 15 went away, now he's left with 9. If I were to add these two values together, it would help me figure out the value for t. We can act that out here. This can represent t. When we subtract the 15, we're left with 9. Okay, so if I were to add 9 plus 15 together, it would tell me t. That's 24. Let's see if that makes sense. Is it true that 24 minus 15 is 9? It is true. Okay, so that means that my equation that I wrote, t minus 15 equals 9, I did it right. Sometimes checking your work can help. Okay, now, about to blow your minds, you did not have the back on your math minutes. But I'm showing it to you now. So I'm going to show you these Wednesday problems. You can flip your paper over in your packet, and you can pause the video now and try it first. Then press play. And check your work. Okay? All right. 28 divided by 4 plus 9 times 7. That's weird. Why would they write that out? Okay. I did not make these. Okay. So this looks like order of operations. So off to the side, I'm going to write PEMDAS. Okay. So I always start with parentheses. In middle school, they call it groupings. Then I go to exponents. Then I either multiply or divide. And now that we've learned fractions, you know that multiplication and division are pretty much the same thing. And I either subtract or add, and next year you'll learn that those are also the same thing. That's why in middle school, they just write this. GEMS. Groupings, exponents, multiplication, which is also division, and subtraction, which is also addition. Okay, side note, in case any of you have any older siblings and they tell you that they do GEMS. Okay. It's the same thing. 28 divided by 4 plus 9 times 7. So we're going to start with parentheses. Those are called brackets. That's what the groupings mean. But I see two things in parentheses. 28 divided by 4 and 9 times 7. Which one are we going to do first? Okay. The one that we're going to do first is this one, because it's the one that's on the left. When we're doing order of operations, we always go from left to right. Okay, 28 divided by 4 is 7. Then I bring down the rest of the problem. All right, I still see parentheses, so I can't cross that out. 9 times 7 is in parentheses, so I can simplify that. 9 times 7 is 63. Now, I can leave the parentheses, but I don't need them. The only reason why I would need to include the parentheses is if there was a value right here, like 2. That would then mean 2 times 63. But there's nothing there, so I don't really need the parentheses. At this point, I can abandon them. Okay, so now I can cross out parentheses. There's no exponents, and there's no multiplication or division. There's addition, and it's actually just one thing to simplify. 7 plus 63 simplifies to 70. Okay, I'm going to go to the next one. Over here. I will write PEMDAS off to the side, from left to right. Hopefully I left myself enough room here. Okay, so as I look, I do not see parentheses, so I can cross that out. I don't see exponents, so I can cross it out. That's a 6th grade thing. Do I see multiplication or division? It doesn't matter which one I see, it just matters which one's on the left. I only see multiplication, and it's right here. 6 times 9. Okay, 6 times 9 simplifies to 54. So now I'm going to bring down the rest. Minus 3 plus 27. I no longer see multiplication or division. I see subtraction and I see addition. What I do first is what's on the left. So I'm going to start with 54 minus 3. 54 minus 3 is 51. Okay, then I bring down the rest. Plus 27. Now all that's left is addition. 51 plus 27, 78. Okay. I'm going to continue to go down Thursday. Yeah, there's a Friday one too. All right, so I'm showing this to you now. Write it down on the back of your form. Solve it, and then pause the video and wait, and then when you turn it back on, I'll go over it with you. All right, so it says right here for number 7, what is equivalent to quantity 75 minus 9 divided by 3 times 4 plus 17. So what they want here is for us to do use the order of operations. So I'm going to make myself some space here because they didn't really give us much. Okay. Okay, so the first thing I'm going to start with is parentheses, 75 minus 9. 75 minus 9, 66. Okay, I don't need the parentheses anymore because there's nothing right adjacent to it that I would need to multiply, so I can abandon them now. Oh gosh, it's really hard to do this. Let me increase the size. Don't have the best stylus in the world, so this makes it kind of hard. Ugh. Alright, that's supposed to be a division sign. Alright, 66 divided by 3 times 4 plus 17. Alright, so then I'm going to look over here. I'm done with parentheses. There are no exponents. I'm either dividing or multiplying. It depends on which one's on the left. I see either 66 divided by 3 or 3 times 4. I'm going to do 66 divided by 3 because we go from left to right. Alright, 66 divided by 3 is 22. Alright, and then I bring down times 4 plus 17. Alright, so I still have multiplication to do, so I'm going to do that. 22 times 4. I get 88. So I can cross out division or multiplication. I'm left with addition. 88 plus 17, that'd be 105. I'm doing all this mentally, so if I make a mistake, I apologize. Okay? What is it equivalent to? It's the same as 105. Okay. Let's scroll down to see this James problem. James wants to buy 112 tomato plants for his garden. There are 6 tomato plants in a package. How many packages of tomato plants should James buy? Okay. So he needs 112 tomato plants. 6 of them fit into one package. There's 2 operations we could use to solve this. I'm going to draw a bar model to represent. These are all of the plants he wants. Six of them fit in one package. They want to know how many packages. How many packages? So we could either multiply 6 times a number and find when we get to 112, or we could do 112 divided by 6. If we multiply, we'd have to do some guessing. Let's divide. Alright, and again, I'm going to give myself a little bit more space by covering this up. The pen that I'm using to write on my iPad is not the best. Alright, so you can divide 2 ways. We can do the old-fashioned way. Does McDonald's sell cheeseburgers? And I will go ahead and do both methods. 112 divided by 6. 6 is the divisor, 112 is the dividend. We're trying to find the quotient. Okay, so step 1 is divide. Divide. Now look at the 1 right here. This represents 100. 1 divided by 6. Can't do that. So I'll put a 0 up here. Okay, next, multiply. 0 times 6, 0. Next, subtract. 1 minus 0, that's really 100 minus 0. It's 1. Check. 1 is less than the divisor, so we're good. Bring down. Okay, now I'm going to do 11 divided by 6. Okay, so 6 goes into 11 only 1 time. Multiply. 1 times 6 is 6. Subtract. Left with 5. Check. 5 is less than the divisor, so I can bring down a 2. Alright, so I did not do my count bys, but that would have helped me here. So if you want to do your count bys off to the side, you can. 8 times 6 gets me close without going over, because 8 times 6 is 48. And I'm left with a remainder of 4. Alright, so you've learned how to divide with decimals, so we could continue here. We could continue dividing. But let's go back to the problem and see. I could continue dividing. But the problem says how many packages of tomato plants should James buy? Well, if he buys 18 packages, there's going to be 4 plants that he'll have, he won't have enough. There's going to be 4 plants that he's missing. However, if he buys 19, let's see. Oops. If he buys 19 packages, then he'll have 114 tomato plants. Which is more than he needs. So he should really buy 19 packages. That way he has enough. If James only bought... Whoa. Forgot that I covered that up. Let's fix that. Okay, there we go. If James only bought the 18, he'd be a little bit short. He'd be those 4 tomato plants short. So that's why he should buy 19. Okay. So now what I'm going to do is show you the other method to divide, just in case. I know there's a few of you out there that like that method. If you don't like that method, then just move on. You can skip ahead in the video. Okay, so 112 divided by 6. Alright, so when we're dividing this way, partial quotients, I can use what I know. I know that 6 times 10 is 60. So we'll subtract from 112, and we get 52. I know that, let's say, 6 times 5 is 30. Now I'm left with 22 left to divide. Okay, that's supposed to be a plus sign. Alright, so I know that 6 times 3 is 18. And there I get my remainder of 4. Put all this together, and I get 18 remainder 4. We should buy 19 packages so that James has enough. Okay. Friday. The table below shows the total cost of different numbers of notebooks. First notebook is $3.50. You can look at the pattern that's developing here. 2 notebooks is $7.